Welcome to the first set of notes for our pre-algebra class, which is typically Math 8. And our first chapter is all about data analysis. So this section here, we're going to be looking at different ways you could look at data to try to make sense of large groups of numbers. And I was really surprised in college. I kind of wrote it out here, but I was surprised in college and a little bit of grad school how many different fields use statistics. And if you really like math, you can get a great job doing it. Because there's a lot of people that don't like math. They'll pay you a lot of money to do the math for them. But anywho, I digress. But we're just going to start out by looking at these things called line plots. And at first glance, a line plot looks kind of like a number line. But instead of having like 1, 2, 3, 4, 5 on here, what they'll have is they'll have different categories. So, for example, as school starts, there's a lot of students and teachers maybe who have some dreams. So say we're interviewing people, finding out are your dreams are they school nightmares? I've had those before. Or are they dreams about animals or dreams about sports? And so before I do that, I probably should actually go and define what a line plot is. But a line plot is a display of data. So a display of data that shows how many times each data value occurs. So you could just list the number of school nightmare dreams that people in our class had, or dreams about sports. But if you do a line plot, you can see what's going on easier than having to sort through a big list of numbers, especially if you had more than 3 different categories. But for these, what they'll do is above each title, they'll just put an X for each time one of those things has happened. So let's say we had 6 school nightmares in the group. What you'll do is you'll put 6 X's, and you're trying to make them evenly spaced, all one right above the other. So trying to make them same size, evenly spaced. So 4, 5, and 6. So now if we were to say only 2 people had dreams about animals, those 2 should end up being the exact same height as what we had right here for the people with school nightmares. So it's easy to see how this height or this list compares to the first one. So we'll say animals would be those 2. And maybe 4 people then had dreams about sports. So the sports X's should be the same size as the other 2, and it should be twice as high then as the animal list. And in doing something like this, you can really easily see, most people had school nightmare dreams. The fewest people had ones about animals, or twice as many people had dreams about sports as what did about animals. So that's kind of why they go and do it like that. So that's a line plot. So you need to kind of make sure as you study for your first quiz, are they asking for a line plot or a line graph? So a line graph is what you've done a whole bunch of times growing up probably. Maybe you've done line plots too actually. But a line plot looks like this as opposed to a number line type of thing. Then moving on to stem and leaf diagrams. So trees have stems and leaves. With this here, what it does is it uses digits. Let me grab a pen a second. So uses digits, or uses the digits of the data. By that we're talking like the ones place, the tens, the hundreds. Those are the digits. So uses the digits of the data to show the shape and distribution of a data set. So by shape, it's like, are all the numbers connected? Like, are all the numbers close to a certain number, and then the smaller numbers have very few, or that type of thing. But so this here, often I'll just, in class, I'll say, pose this challenge that there's 8 numbers represented in this here. And go through and figure out the 8 numbers, and then I'll give people a little bit of time to work, and they usually pick it up from an earlier class. In a video that doesn't necessarily work, it's kind of for awkward pauses, but feel free to pause it and quick try to write those down. And I'm going to explain now where they come from. But this right here, this side here is going to be just the last digit. And maybe I should make that plural, I'm not really sure, but this is going to be the one before. So all of these here on the right are all the ones digits, and these then will be the tens place. So if I take this combination here, that's going to be my number 21. And then if I were to say this next number, the 2 is still going to be a 20, but then my ones digit is a 4. And then my next one, I still have 20, but now 28. And now when we drop down a row, we have 32. I'll stop doing the underlining, but 36 is another. And then starting in the bottom row, I have a 4 and a 0, so it'd be 40, and then 42, and a second 42. We have to list the 2's twice right there because we want to show that there were 2 different data that had that number 42. So probably should go through and actually kind of label this up a little bit. So we're using common terminology, but when we have the numbers here on the left, these are going to be our stem. So that's the stem. And then the leaves, each one of those numbers I suppose you could call a leaf, but the leaves are going to be those numbers that are here on the side. And it's possible that you'll have 2 groups of numbers. Let's say that this group here represents the amount of money in our dad's wallets. So people went home last night, and one dad had $21, that right there. Another dad had $24 there, and so on. Let's say we wanted to have in this same data representation the amount of money in the mom's wallets, or purses, or whatever they might carry money in. So then they'll do what's should be new this year, I think, for you guys, is a double stem and leaf plot. And it looks similar in that the first digit, the first digits, sometimes you'll have like 2 numbers here. But this here is going to be the first number. And then we just put the last digit of the amount of money that they have right over there. And I'm going to make a little bit more room here. But let's say then someone went home. Oh, the other thing is that they will have the smallest numbers close to the stem. So here we go 1, 4, 8, and 2, 6. If we have a 1, 4, 8, we'll have the 1 here, then the 4, then the 8. That you always start at the stem and go larger as you go out. All right, so I'll just write a couple numbers over here on the sides. Let's say one mom had $23. Another one had 37. Another one had 32. And one had 58. All right, so let's put those numbers in. So the 23 we'll take and we'll put that, well, we have the 2 right here. So then 23 is going to go right there. So 23, we'll write a 3 here on the left. So I write in a 3. I have 2 numbers in the 30s. I have 37 and 32. So we have to put the 2 right there because that's the smaller number than the 7. So that represents 32, put a 7, now we have 37. And last but not least, we have this 58. And for 58, we're going to take and actually add a 5 down here, and then put an 8 right next to it there. All right, last thing, I have a challenge for you. And here's a data set going back to when I was a kid. The Chicago Bulls were awesome. So they had Scottie Pippen, Michael Jordan. You've probably at least heard of Jordan. So scored a whole bunch. I mean, they're good. Especially Jordan was amazing. But okay, so say we want to put this data in a stem and leaf diagram. So I'd pause the video and give it a shot. And I'm going to quick explain it and write it out in a second. So, all right, so hopefully you paused it. If not, we're kind of spoiling the adventure here a little bit. But one thing you have to notice is that you have to do a double stem and leaf plot. So for this one, we'll take and we'll put the 2 lines. That's going to be our center numbers. And it's probably a good idea to start by looking at how many different first digits do you have. And this number right here is one that sometimes causes people grief, because what do you do with a single digit number? Well, the 9 has to go on the leaf portion, one of those. So that's actually going to be a 0, 9 if we're looking for a first digit. I'm going to put in a 0. And then we have to have some 1s as a first digit for a couple numbers down here for Scottie Pippen. So we put in a 1. And there's tons of the things that are in the 20s, so we'll put a 2. And then last but not least, we'll have a 3. Now I have to decide which side Michael Jordan's going to be on, which side Pippen's going to be on, and it really doesn't matter. I'm just going to kind of work top to bottom, left to right. So I'm going to put Jordan over here on the left side. You don't have to label it. I think it makes a little more sense if you do, but I'm going to put a J for Jordan, a P for Pippen, and then go through and look for numbers. So what could be helpful is to take and write all the numbers for one of the persons in order. I'm probably going to skip that right now, but I'll start by doing Michael Jordan here on the top row. And so he has nothing in the 0, nothing in the 10s, but he has 4 numbers rather in the 20s. Nope, he has 5, so he has these and those. So the smallest last digit is a 2, so I'll put a 2 right here. That takes care of my 22. I'm going to cross them out just so I don't lose anything, forget anything. Then he has a 23. Then he has a 26. Then he has a 28. Last but not least, he had a 29. Then he had a 36. We'll put a 6 right there. So Michael Jordan's done. Got the last 2. Some people go through and count up how many data items they have here and then compare it to that there should be 6. I like crossing them out as I go. Last one is for Pippen. So we have this one here, which is the 0, 9. So I could put a 9 right there. In the 10s, he has 3 different numbers. So he has 12, 14, and 17. So a 2, a 4, and a 7. And then in the 20s, he has 2 numbers. They're both 21, so we put a 1 and a 1. And that would be it for the stem and leaf. So this is nice because you can look and see who scores the most. Okay, usually Jordan scores more than Pippen because he's kind of clumped up down here. Well, what are his scores usually like? Oh, usually Jordan scores in the 20s, but sometimes he gets in the 30s. How about Pippen? Well, he's usually in the 10s somewhere. So you can kind of easily glean information out of the data using these stem and leaves. All right, very last thing, the range. If you're talking about the range of the data, the range is defined as the difference between the highest and the lowest value. So difference, if we're trying to find the difference, how do we do that? And the key there is it's always going to be subtraction. So difference between the highest and the lowest number. So basically, if you wanted to write it out, you could say biggest or highest minus the smallest. So in other words, if we were to be doing Michael Jordan's range from the problem before, his biggest number is represented right here. It's going to be a 36. And his smallest number is right there, which is a 22. So the range of his data is 14. That's it.